War is often seen as a clash of steel, a battle of firepower and tactics, where ammunition and rations dictate the victor. But, ask any soldier who has faced the raw, unforgiving reality of the front line, and they'll tell you a different story. In the sweltering jungles of the Pacific or the arid deserts of North Africa during World War II, a far more pressing enemy stalked every platoon: thirst. A soldier can survive for weeks without food, but only a few days without water. Dehydration clouds judgment, saps strength, and turns a fighting force into a vulnerable, stumbling mess. It was the silent killer that logistics officers often overlooked in their frantic rush to supply bullets and beams. Yet it was the one thing that could bring an entire army to its knees, faster than any enemy barrage. Imagine the scene. A small unit cut off from their supply lines behind enemy territory. Their canteens are nearly empty, the water inside warm and tasting of metal. The only source of water is a muddy stream, potentially teeming with dysentery, cholera and other invisible enemies that could incapacitate a soldier as effectively as a sniper's bullet. This was a common and honestly terrifying dilemma. Leadership knew that providing safe, drinkable water was not just a matter of comfort, but a critical component of operational effectiveness. A sick soldier is a liability requiring care and resources that are desperately needed elsewhere. The search for a reliable water source became a constant life-or-death mission in itself, a battle fought not with rifles, but with ingenuity and desperation. The High Command poured immense resources into logistics, focusing on massive supply chains for fuel, ammunition, and pre-packaged rations. Water, however, was a different beast. It's heavy, bulky, and needed in vast quantities, making it incredibly difficult to transport to remote or rapidly advancing fronts. While purification tablets were issued, they were often in short supply and couldn't always be trusted, especially with heavily contaminated water. Boiling was the gold standard for killing pathogens, but it required fuel, time, and a fire that could give away a unit's position to the enemy. In the heat of battle, these were luxuries that soldiers simply did not have. They needed something simple, quiet, and effective. This desperate need for a field-expedient solution forced military engineers to look beyond modern chemical treatments and back towards a method that had been proven for over a century. They needed a system that could be built with whatever was available, operated silently, and produced safe water without fail. The answer was found tucked away in old engineering manuals, a technique that harnessed the power of nature itself to do the purifying. This wasn't a high-tech gadget or a complex chemical formula. It was a brilliantly simple process that any soldier could learn and implement. This nearly forgotten secret weapon was slow sand filtration, a trick that would save countless lives when all other systems failed. Tucked away in dusty military engineering manuals from the era was the blueprint for a survival technique that felt almost too simple to be true: slow sand filtration. This wasn't a new invention. Cities had used large-scale versions of it for nearly a century to purify municipal water supplies. What World War II engineers did was brilliant in its simplicity. They adapted this large-scale industrial process into a portable, field-ready system. They recognized that the core principles didn't require massive concrete basins or complex machinery. All it really needed was a container, layers of sand and gravel, and the one thing every soldier had in abundance: patience. It was the ultimate low-tech, high-impact solution for a desperate situation. The beauty of the slow sand filter was its accessibility. While specialized equipment was often lost or destroyed in combat, the components for this filter were everywhere. A discarded fuel drum, an ammunition box, or even a helmet could serve as the container. Sand and gravel could be sourced from riverbeds or creek banks. The system didn't rely on a fragile supply chain or complex parts that could break. This resilience made it the perfect tool for isolated units, guerrilla fighters, and reconnaissance teams operating deep in enemy territory. It empowered soldiers to become self-sufficient, turning a contaminated water source from a deadly threat into a life-sustaining resource, a true game-changer in a survival scenario. Unlike boiling, slow sand filtration was a silent and stealthy process. A fire to boil water produces smoke and light, acting as a beacon for enemy patrols and artillery spotters. In the dead of night, the flicker of a small flame could mean the difference between life and death. The slow sand filter, by contrast, worked quietly in the background. Once set up, it required minimal attention, slowly and methodically dripping clean water into a collection vessel. This allowed soldiers to focus on guard duty, maintaining their weapons, or getting much-needed rest, all while their water supply was being replenished safely and discreetly, hidden from prying eyes. The psychological boost this provided cannot be overstated. For soldiers surrounded by uncertainty and danger, having a reliable source of safe water was a massive morale boost. It was one less thing to worry about, a small piece of control in an otherwise chaotic world. Knowing that the water they were drinking wouldn't make them sick gave them the confidence and physical strength to continue the fight. Real wartime accounts tell of units that were able to hold out for days against overwhelming odds. Their survival credited not to their firepower, but to the simple, steady drip of a sand filter they had built from battlefield scraps, a testament to its life-saving power. The real magic of the slow sand filter isn't just about straining out mud and silt. That's only the first step. The true purifying power comes from a slimy, biological layer that forms on the very top of the sand. The Germans had a wonderfully descriptive name for it, the Schmutzdecke, which literally translates to dirt cover. This isn't just dirt, it's a complex living ecosystem. A vibrant community of bacteria, algae, protozoa, and other microorganisms establishes itself in the top few centimeters of the sand. This living film becomes the primary barrier that wages war on the invisible enemies lurking in the water, a microscopic battleground that ensures the water becomes safe to drink. Here's how this incredible natural process works. As the contaminated water slowly seeps through the Schmutzdecke, the beneficial microorganisms in this layer get to work. They are hungry. They actively prey on and consume harmful bacteria and pathogens such as those that cause cholera, typhoid, and dysentery. It's a process of biological warfare on a microscopic scale. This biological action is far more effective than simple mechanical straining, which might only remove larger particles and parasites. The Schmutzdecke effectively eats the danger, transforming contaminated water into something potable. This is why the filter must be run slowly. It gives this biological layer enough time to do its vital work. This biological purification is what sets slow sand filtration apart from modern filters that rely solely on a fine physical mesh. While a ceramic or hollow fiber filter can physically block bacteria, it does nothing to neutralize viruses, which are often small enough to pass through. The Schmutzdecke, however, can even help reduce viral loads through processes of adsorption, where viruses stick to the biological matter. It's a comprehensive, multifaceted purification system designed by nature itself. This living layer is the filter's engine, and it's crucial to let it mature for a day or two to become fully effective, a process soldiers had to account for when setting up their camp. The dependability of the Schmutzdecke is its greatest strength. It is a self-regulating, self-maintaining system. As long as it is fed with a steady, slow flow of water, the microorganisms will continue to thrive and purify. Unlike chemical tablets that run out or mechanical filters that clog and require backflushing or replacement cartridges, the Schmutzdecke just keeps working. If the flow rate slows down over time due to buildup, the solution is simple. Gently scrape off the top centimeter of sand, removing the oldest part of the biological layer, and a new one will quickly form. This simple maintenance could be done indefinitely, providing a near-endless supply of safe water. The genius of the World War II era slow sand filter is that its design is, well, honestly, just timeless. Today, any survivalist, homesteader, or prepared citizen can build one using modern materials that are cheap and, readily available. The principles remain exactly the same. You will need a food-grade bucket, around 5 gallons is perfect, a small spigot or tap, some tubing, and the filtering media coarse gravel and fine sand. The sand is really the most important part. You want playground or pool filter sand, not sand from a beach, since that contains salt and organic matter that can interfere with the process. Your goal here is to create a layered system that mimics what those soldiers built in the field. Let's get building. First, you'll drill a hole near the bottom of your bucket and install the spigot. This will be your clean water outlet. About 2 inches above that outlet, drill another small hole for an overflow tube to prevent water from running over the top. Inside, cover the bottom of the bucket with a layer of coarse gravel, about 2 inches deep. This layer prevents the fine sand from clogging your spigot. On top of the gravel, you'll carefully add your main filter medium, about 12 to 15 inches of fine sand. Before adding the sand, make sure to wash it thoroughly to remove any dust and silt until the water runs clear. Once your sand is in place, you need to protect it. Place a small plate or a flat rock on top of the sand bed. This is crucial because you'll be pouring untreated water into the bucket, and you really don't want the force of the water to disturb the top layer of sand where the precious Schmutzdecke will form. Now, you can start the filter. Slowly add your untreated water, letting it fill the bucket until it is a few inches above the sand. Open the spigot just a tiny crack so the water drips out at a very slow rate, no more than 1 liter per hour for a 5-gallon bucket. This slow speed is essential for the biological layer to form and do its work. The final and most important step is patience. For the first 24 to 48 hours, the water coming out is not yet safe to drink. The Schmutzdecke is still forming. You should discard this initial water or use it for cleaning. After a couple of days, your filter will be ripe, and the living biological layer will be actively purifying the water. From this point on, as long as you keep the sand bed wet and top it off with untreated water, the filter will continue to produce safe, clean drinking water. You have now built a reliable off-grid water purification system, a modern lifeline based on battle-tested, life-saving wisdom from the past. In our modern world, we're honestly surrounded by high-tech gadgets promising instant solutions for every problem, including water purification. We have UV sterilizing pens, advanced hollow fiber filters, and chemical tablets that promise safe water in just minutes. These are fantastic tools, but they all share a common vulnerability. They can fail, break, or run out. A UV pen's batteries can die. A filter can clog beyond repair in silty water. A bottle of purification tablets can be lost or used up. When technology fails in a crisis, whether you're a hiker lost in the woods or a city dweller facing a natural disaster, you're left with nothing. This is precisely why the wisdom of the slow sand filter endures. It's important to be clear about what this method can and cannot do. A slow sand filter is incredibly effective at removing protozoa like Giardia and Cryptosporidium, and bacteria like E. coli and Salmonella. It is less effective against viruses and cannot remove chemical contaminants like pesticides or heavy metals. Therefore, it's always best to use the cleanest water source available, avoiding runoff from industrial or agricultural areas. For ultimate safety in a modern context, you could follow up the filtration by boiling the water or using a tiny amount of bleach. But in a raw survival situation where that isn't possible, the filter alone dramatically increases your odds of staying healthy. The lesson World War II engineers left for us is more profound than just a water filtration technique. It's a philosophy of survival. It teaches us to look for solutions in nature, to understand and work with natural processes, rather than always trying to overpower them with technology. The Schmutzdecker is a perfect example of harnessing a living ecosystem to solve a human problem. This mindset is invaluable for anyone interested in self-reliance. It encourages us to learn timeless skills that depend on knowledge, not gear. Knowing how to build this filter is a skill that weighs nothing, can't be broken, and can be deployed anywhere in the world. Ultimately, the humble, slow sand filter is a powerful symbol of resilience. It represents the idea that the most robust systems are often the simplest ones. While we should absolutely take advantage of modern technology, we must not become completely dependent on it. The old ways, born from necessity and perfected through hardship, offer a fallback that will never become obsolete. Whether you are facing a battlefield, a natural disaster, or an unexpected wilderness emergency, the enduring wisdom of our grandparents' generation might just be the thing that saves you. True preparedness is not about what you have, but what you know.